Hi, everybody. Welcome to our webinar today, Electrical Panel Upgrades, a Key to Scaling Home Electrification. My name's Joe Wachunas, here as always with Brian Stewart, founder of Electrify Now, and we've got a really great program today with some fantastic panelists who we'll introduce shortly. Want to wish everyone a happy Indigenous Peoples Day today. We're really honored to be having our first day of Sustainable Building Week on Indigenous Peoples today. From time immemorial, our Indigenous communities have been stewards of the environment, so we are really honored to honor them today. So welcome. We are, if this is your first time to an Electrify Now webinar, we are Electrify Now, an all-volunteer organization that believes that electrification is the quickest and easiest path to decarbonization. We boil our message into four easy steps. Number one, clean up your electric supply through solar energy or your utility renewable program. Two, electrify your home. Today we're going to be talking about a piece of that, the electrical panel. Three, electrify transportation. If you go to our YouTube page, Electrify Now, just Google Electrify Now YouTube. We did a webinar last month on electric vehicles. And then number four is electrify everyone. We'll put information to this great program that we run with the Community Energy Project in the chat. But I want to introduce you to Webley Bowles from New Buildings Institute to talk to us a little bit about Sustainable Building Week. This is the kickoff event for Sustainable Building Week. Webley, go ahead and take it away.
Thanks, Joe. So my name's Webley. I am a co-founder of Sustainable Building Week, and I am so happy that Electrify Now is the first official Sustainable Building Week event. We are so happy to our sponsors and to the great organizations that are involved with Sustainable Building Week. If you are new to Sustainable Building Week and want to get involved, check out who the sponsors are, those that are collaborating and doing events this week. These organizations are Portland's leaders on the topic. And Joe, if you go to the next slide, just want everyone to know that we have 32 events, 28 of them are free. 21 are in person if you are in Portland, Oregon. 12 of them are online. So if you're not in Portland, you can still participate, which is great. And this just happens once a year, but it's only possible because we have great organizations like Electrify Now that are holding events continuously to spread sustainability. So thank you, Joe and Brian, for all that you do. I'm going to put the link to Sustainable Building Week in the chat so you can see more of the events, and thanks so much.
Great, yeah.
Thanks, Webley.
Highly encourage everyone to check out Sustainable Building Week. Such a wonderful series of events, and we're so honored to be kicking it off today with our great panel. Just real quick, we are at Electrify Now. We are doing 4 events in Sustainable Building Week, and we'll put links in the chat room shortly to these events. Tomorrow, we're going to be having our own Cora Wyand from Rewiring America back to talk about the Inflation Reduction Act. What's in it for you? Don't want to miss that one. On Wednesday, want to put a huge plug into induction cooking in commercial kitchens. We're going to have 2 professional chefs on the webinar to talk to us about how to use induction to cook in general, and especially in commercial kitchens, think to restaurants or campuses. That's going to be amazing. We're very excited about that. And then on Thursday, we're going to be talking about how to electrify equitably. We're going to be with the executive director of Efficiency Maine to talk about their equitable electrification programs, as well as the Portland Clean Energy Project. We'll put links to those in the chat. And I want to give a quick shout out to our heat pump water heater webinar at the end of the month. That's going to be part of Heat Pump Water Heater Day with the Advanced Water Heating Initiative. We're going to have all the manufacturers from every heat pump water heater on that webinar to talk about them. So you don't want to miss that one. Okay, Brian, why are we talking about electric panels today?
All right. Well, yeah, it's kind of one of those funny things where the all this focus on electrification has brought attention to this little thing that's in your basement or your garage or somewhere. Most people don't even know where it is. That's become kind of one of the most important players in this whole conversation about electrification. And this is because, in general, the word's getting out that all electric homes are better homes. I mean, maybe it's still in the building phase, but this trend towards all electric homes is something we're starting to see. You can see it in terms of the furnace sales versus gas furnace sales versus electric heat pump sales, for example, and other data where home electrification is on the rise, and the reason is because they're safer and healthier. Air quality, performance, all the even some of the appliances are less likely to cause problems like fires and burns and that sort of thing. They're way more energy efficient than mixed fuel homes or gas powered homes. They're more comfortable, partly because of air conditioning and partly because of just better uniform heating with heat pumps, etc. And they produce far fewer carbon emissions, which is another reason why a lot of the trends in building codes and other legislation is tipping the playing field towards all electric homes. And then, of course, they have the potential to be zero carbon as the grid gets cleaner and cleaner and cleaner everywhere in the United States. So because of this, there's just more homes that are wanting to be all electric. And if that's quite straightforward if we're building new homes. But what about the homes that are already here? And if you look at the building stock in the United States, what you see is that a lot of our homes are relatively old, and that's not a bad thing. I mean, a lot of people like older homes. We live in one, we love it. But you can see here that, big chunk of the homes are over 50 years old, 40% or so, are over 50 years old. And back to the electric panel thing, what that means is the early standards for electrical panels were quite modest in terms of the amount of power that was really kind of partitioned off for each home. And it was not until the 80s when the 200 amp panel started to become really common in homes. So you can see that, and this is what we're going to dive into in more detail, a lot of older homes have smaller panels. And so that means that we have to have ways to deal with that as we bring more electrical loads into those homes. So today we're going to focus on this unsung hero of the electrification project, the electrical panel, and we're going to be talking about why this is an issue, what are the typical costs if you need to upgrade, and we'll talk about if you even need to, which is one of the exciting things that we're going to dig into. We'll talk about this exact thing. Is it possible to electrify your home without a panel upgrade? And what are circuit sharing devices, for example, and how do they help? And what about smart panels? What do they do? What are those benefits? Where do they fit into the big picture? And then, of course, one of our favorite pieces of legislation, the Inflation Reduction Act, does have money in it, and we'll talk about what that might look like in case panel upgrades are required. All right, so that's kind of what we're going to be up to today. I want to introduce our amazing panelists, and starting with Cora Wyant. She's a research associate at REWIRING America, one of our favorite organizations. We do a lot of work with them. Cora is conducting research and analysis to enable rapid electrification of everything in the economy, and she'll talk more about that in terms of the focus of REWIRING America. Prior to REWIRING, she was a PhD candidate and completed her PhD in physics at Caltech, where she studied materials for ultra-thin solar cells and carbon capture technologies. So we're excited to have Cora here from REWIRING America. Then we'll be hearing from Hannah Brugman. She's the director of programs at Build It Green, an amazing nonprofit in California who's devoted to creating healthy housing ecosystems that foster the well-being of individuals, communities, and the natural world. She has an MS in product design from Stanford University. So do I, by the way. Hannah, we didn't get a chance to talk about that. And she has a BS in physical geography from Arizona State University. Exciting to have Hannah here talking to us about panel optimization and other little things that's good to know about panels. And then we're going to wrap it up with Chad Conway. He's head of products at SPAN. SPAN is one of the leaders in smart home electrical panel technology. They've really been pioneering this field and have some amazing products that we'll hear about. Before SPAN, Chad helped build the Tesla Powerwall product line. So he's really familiar with home electrification and the loads that are associated with that. And he was built that development team before joining SPAN. He graduated from Rose Holman Institute of Technology with a BS in mechanical engineering. So he's one of those smart engineering guys who knows a lot about stuff. With that, I'm going to turn it over to Cora to get us kicked off, and let's do it.
And as you're doing that, Cora, and getting the slides up, I'll just let folks know, please put your Q&A for the panelists in the Q&A button. And if you feel comfortable sharing where you're tuning in from today, go ahead and put that in the chat. Thanks so much.
Awesome. Great. Thanks, Brian and Joe. It's great to be here. I'm excited to be talking about electrical panel upgrades today. And funnily enough, given the title, not upgrading electrical panels too. So first of all, some quick background on my organization. I'm from REWIRING America. We're a nonprofit founded in 2020 with the broad idea to electrify everything. So we do some research, we do some policy advocacy, and some private sector partnerships. And when we talk about electrify everything, this means the cars that we drive, it means how we heat our homes, how we cook our food and dry our clothes, and then where our electricity comes from. And we've done some fun sort of calculations of what it actually means to electrify all the machines in the United States. How many machines is that? And it turns out that that comes out to about 1 billion machines. And that turns out to be about 100 million stoves and space heaters. So turning space heaters from fossil fuel, natural gas furnaces to clean electric alternatives like heat pumps. And then for EVs, there's about 200 million of those that we need to transition from combustion engine to electric vehicles, and a number of other machine types. But this also means that we need new household infrastructure to support this sort of rapid electrification of the economy. So we need some new solar panels, we need some new batteries, we need some new EV chargers. And then what we're talking about today is that we might need some new electrical panels or smarter ones or some other devices that help us use our current electrical panels more efficiently. Okay, so first of all, what's an electrical panel? I had a friend the other day who was like, oh, all the lights went out in this room of my house. I don't know what to do. He moved into an apartment for the first time. And I was like, well, go flip your breaker. And he was like, what's a breaker? What's an electrical panel? So in case you don't know what an electrical panel is, this is what it looks like. This is my electrical panel in my house. It's usually a gray box that's in your garage or your basement or outside somewhere. And it's basically the thing that interfaces between the utility's power grid and all of the outlets and appliances in your home. So it's got what's called the main breaker up here, which turns your entire home's electricity on and off. And then it's got a number of branch circuits, which basically send electricity to different parts of your house. And your main breaker usually has a number on it here that tells you how much electrical service you have. So mine says 200, which means I have 200 amps of electrical service. And then all these individual branch circuits also have smaller breakers that have numbers on them that show you how many amps of electricity can flow to one of those given circuits. So my background's in physics, so I had to throw one equation in here, which is that power in watts or kilowatts is equal to current, which is measured in amps, times voltage, which is measured in volts. And current basically tells you how much electricity is flowing, and voltage tells you how much energy that electricity carries. And then when you multiply those two things together, you get the power of a circuit or of an appliance or something like that. So for an example of an EV charger, fastest one you can get in your home, if you have you might have like a 50 amp circuit with 240 volts. If you multiply those together, you get 12 kilowatts of power. And then your actual appliance that's on a circuit usually uses less than that circuit is actually rated for, just for safety. So the EV charger might be drawing 10 kilowatts of power at its maximum output. So you can kind of go through and look at all your different circuits in your house and calculate for this current, and a normal circuit's 120 volts. You can calculate how much power each circuit is drawing. So this shows you the typical power of a number of different appliances in an all-electric home. So if you're going to get an electric dryer, those usually require a 30 amp circuit. An electric stove requires a 40 amp circuit, and you can see what the power ends up being. When you sum all of those things up, and then you do some math that's specified by the National Electric Code, you end up with the amps of service, or the panel amps that you need to provide electrical service to that home. So for this all-electric home here, that ends up being 120 amps. So if we just took that at face value, and this home was a 100 amp panel that needed to sort of add all these new loads, we would say, okay, this home needs a panel upgrade to have higher electrical service than 100 amps, because that 121 amps is not going to fit on your current panel and your current electrical service. So if we look at across the whole US, Joe and Brian talked about sort of the older homes tend to have smaller panels, 100 or 60 amp electrical panels. And there's actually not great data on exactly how the panels are sized across the whole US. But we've done some estimations by looking at surveys of specific areas or by looking at home age and home size. And we estimate that about 60% of houses in the US have less than 100 amp service or equal to 100 amp service. And if we were to say, okay, let's electrify everything, and because of that, let's upgrade the service of all of these panels across the US, that could be a pretty expensive and lengthy process. There was a recent study that was put out by Redwood Energy and NV5 that showed that service upgrades can cost anywhere from $2,000 to $30,000, and they can take months sometimes. So how do you electrify a home with an 100 amp panel? Fortunately, you have options. You don't have to just do a service upgrade, although that can be a good option for some homes. So option number one is get an electrical panel and service upgrade. This is the most prevalent solution, but it's not great for the grid. It could be expensive. Option number two, which Hannah's going to talk about in a lot of detail, is panel optimization. So choosing power efficient appliances and circuit sharing devices so that you can electrify even with a 100 amp panel. And then finally, option three is using technology like smart panels that kind of automatically regulate your home's electricity demand to stay under a certain current limit. And then if you do end up needing to go with option one and upgrading your electrical service, there are really good incentives in the recent climate bill that got passed, the Inflation Reduction Act. And you'll hear a lot more about that if you come to the Electrify Now webinar tomorrow on the Inflation Reduction Act. But here are some of the rebate amounts that you can get for your panel or your wiring. And the way these work is these are designed primarily for lower and moderate income households. So if you're a lower income household, you can get 100% of your electrification costs covered up to these sort of caps on per equipment. So you could get up to $4,000 for a panel upgrade and up to $2,500 for wiring. And then if you're a moderate income household, so that's 80 to 150% of the area median income, you can get 50% of your electrification costs covered up to these same per equipment caps. And then for market rate households, there's also a 30% tax credit up to $600 for upgrading your electrical panel. That's part of the 25C tax credits. And I know we have some builders on the call today, so I want to mention that from our understanding, you can take these rebates for basically for new construction, as long as it's built for a homeowner that meets those income requirements. So it can't be sort of just a spec home, it has to be built for a certain person. So then finally, we did sort of a fun project with SPAN that Chad's going to talk about a little bit more later, but I wanted to share one quote from this white paper that we wrote with them, which I think kind of highlights the challenge that we're talking about today, which is that our grid is built for the worst case scenario, the short, rare instances where households are using all of their machines at once. This is an inefficient use of electric infrastructure and makes scaling our electric grid to support an increasingly electrified economy harder than it needs to be. So with that, I want to pass it off to Hannah and then to Chad to talk more about how we can more efficiently use our electric infrastructure and build our grid to support sort of what a household actually needs rather than this absolute worst case scenario of everything being on all at once. So I will stop sharing and pass it to Hannah.
Thanks, and maybe while Hannah's getting her slide up, we did have one question, Cora, that maybe we could catch right now. Do you have an idea about what's the timing of those incentives from the IRA in terms of when they will be available?
Yeah, great question. So the tax credits become available on the first of of next year. So starting right in 2023. The rebates should be available sometime in 2023, but it's up to states to design the programs to distribute those rebates. So the timing of those rebates is a little bit more uncertain.
Thank you.
Super. Can you see my screen?
Yep.
Great. Just quickly, hello, everyone. Like Brian said, I'm Hannah. I work at Build It Green. We've been around for almost 20 years, really caring about sustainable buildings, how we build them, how we make healthy and thriving communities. And in particular, I'm here as a representative of a working group that we've put together that is really working to make electrification more accessible to everyone and really focus on this electrical panel issue. So we've got utilities, national labs, a lot of great smart folks doing this work. So I'm representing all of them here today. And if anyone's interested in joining this working group, also you'd be welcome to please let me know. This is what we're going to cover. Like Cora said, I'm really going to focus on the panel optimization piece of the solution. Brian already mentioned why all electric homes are really important. One quick thing to note about Build It Green, we're based in California. So a lot of my examples are California centric. That's not that I don't love other places. That's just where we have the most experience. So for example, there's been studies done by the National Resource Defense Council that buildings in California are responsible for roughly 25% of climate related emissions. So that's actually quite significant. California is a little unique in that we use a lot of natural gas in our homes. And only 8% of California homes are all electric, at least as of 2020, which is pretty low. And like Brian also said, there's a lot of health and safety risks associated with that. And so what we're really interested in when we're thinking about panel optimization and the whole kind of purpose behind this approach is how do we, as quickly as possible, as cost effectively as possible, and as equitably as possible, allow people to electrify their existing homes, because we just think that's super important. I love that folks put where they're from in the chat. Looks like there's folks in California, but a lot of folks from other places. So this map just gives you a sense of roughly how many homes are already all electric and how many might really need to be thinking about panel optimization going forward. This is from the Energy Information Administration. The lightest green, of which you'll notice there are a lot of states, have pretty low rates of total electrification. So if you live in one of these states, except surprisingly, or maybe not, Florida, this is something that you might be needing to consider as you think about updating the systems in your home. So in order to electrify, in a lot of cases, you may or may not need more electricity. This is kind of the electrical panel is kind of like the control center for the electrical system in your home. And that's why it's so important, even though you may not have thought about it unless you were like Cora's friend who blew their circuit and had to go figure out how to reset it. Like Brian said, in new homes being built, it was standard because of the National Electric Code to require only up to 100 amp panel until the mid to late 60s. So in the East Bay, where I live in California, the median age of home is 1942. So we have some pretty old homes where we live. That's different, obviously, for different places where you are in the country. But it means, like folks have already said, this is pretty important. And in particular, because this can be extremely expensive, just in the state of California, there's been estimates of $25 to $40 billion to cover the costs of just doing electrical panel upsizing for all the homes kind of roughly estimated in the state. So all of this is just to give you a sense of the scope of the overall challenge. Cora mentioned this, and I'm going to go a little bit more in depth using the same study because there's actually not great information, believe it or not, on how expensive this typically is. So if you're asking it in the chat or the Q&A, like how expensive will it be for me to update? It's really hard to say. It really depends how close are you to a pole with a transformer? Are your wires underground, or do they come overhead to you? How old is the infrastructure in your community? Which you might not have any idea about, because that's something that your power utility or electrical utility fully controls. So one of my friends tried to upsize their panel. It was wildfire season here in California. PG&E was not able to come out and help them for almost 6 months. So not only is it like the net dollars, but it can take a lot of time. And like I said before, this is really urgent. And if you're in the situation where you need to replace your heat pump hot water heater, which is usually a replacement that people make in kind of an emergency scenario, but you want to go all electric, you might not have 6 months, unless you have an incredibly tolerant family and really love cold showers, to wait to do those upgrades. And to be specific, this is just that gray box on the side of your house and the associated wires. It actually doesn't include all of the investments that the utility might have to make to be able to get you that additional power. So there is infrastructure that in beautiful communities is more or less invisible. In some communities, you can see just all the wires hanging up there, the transformers, the poles. All of those might need to get upgraded as well, depending on the utility and the age of that infrastructure. So there could be additional costs borne both by you as the homeowner or property owner and the utility. So another reason that we really like the power optimization approach is it's really grid friendly. It's also neighborhood friendly. It allows your neighbors to electrify pretty equitably and quickly as well, because you don't have to wait as long or have the utility come and kind of upgrade all of that infrastructure, which, like I said, can be a big cost. That's not to say that sometimes you absolutely won't need to do an upsize. Like Cora said, the home that I moved into had a 30 amp fused panel. Obviously, that was not really going to be quite enough to do what we needed. And there can be damage and other things like that. But still, if you're thinking about moving in the direction of electrifying your home, even if you're upsizing, it still really makes sense to think about your whole home electrification plan. Are you going to want an EV, multiple EVs? Are you in a position to have kind of more luxury elements like pools or spas that you might want to also take all electric? Thinking about those, if you can in advance, will help you do this in the most cost-effective and quickest way to get the best results. So let's actually talk about panel optimizations. So when we say upsizing or upgrading, this means getting both a larger piece of technology on your home and or getting more service from the utility. But you can avoid it. Like Cora said, I just gave the two options here of panel optimization planning and then using various kinds of technology to help kind of balance overall load. Thank you so much, Tom, for sharing that calculator in the channel. Tom Cobbett is here. He helped put a lot of this together, so he can also help answer any questions that you have as we go through this. So the work that he and others have done have demonstrated that you can feasibly, effectively, and comfortably, more importantly, electrify your home, a very reasonably sized home, at only 100 amps. And there's just a couple of things you need to think about when you do that. One, choose your appliances carefully. So different appliances use different amounts of power. So you're probably familiar with energy efficient. You probably have LED light bulbs in your home. They use much less electricity to provide the same amount of light. Power efficiency is very similar to energy efficiency. One way to think about it is your heat pump hot water heater can either gulp energy, like drinking an entire cup of water all at once, or it can kind of sip that water over time and receive the same amount of hydration, but just over a longer period of time. So if you have a power efficient heat pump hot water heater that uses, say, 15 amps of power versus 30 amps of power, you will still have a beautiful and luxurious warm shower whenever you might want and everybody else in your home, but it'll use power at a slower rate over time. So if you do that, you then have more availability on your electric panel to add other devices, other appliances that also are all electric. Like Tom Cobbett put in the chat, Redwood Energy, in partnership with others, put together a calculator to help you think through what does it actually take to add all of these things together. How can you think about approaching it? One thing that's great about this is you can do it right now with technologies that are fully available on the market, and more are coming out as we speak, which is really exciting. I don't know if you're going to cover it in, the heat pump webinar you have later this week, Joe, but there's now heat pump hot water heaters that you can plug into a standard 120 volt plug, and other things like that, plug-in heat pumps, etc., that allow you to do this right away, relatively quickly, without blowing your panel. Some of you, like Cora said, may or may not be familiar with the technology of your electrical panel to figure out even how much service you have. So I just threw this in here to help you quickly think about or figure out how much service you have. So in this illustration, the little red on top, if you can find your primary panel, not a sub panel. So if you have a smaller panel that's like near your kitchen, that's a sub panel, probably not your main panel, will tell you how many amps you have. However, there are situations where the size of your panel is not actually the amount of service that is reaching your home. For example, my parents have a 200 amp panel, but they only have 125 amps of service to that panel. So just something to be aware of as you're looking for this. There's a lot of other ways to figure it out. Google is a fabulous source of giving you much more detail than I'm capable of in this conversation to do that. So, quick summary of strategies. Choose power efficient versions of those appliances, like I already said. This one is a little bit less sexy, but actually very important, more affordable, and really will help with comfort. And that's insulation and air sealing. So if you don't have insulation, or you don't have enough insulation in your attic, your walls, working on improving that insulation and filling in gaps. That's what air sealing is. So if you have gaps around your windows or similar, if you're spending a lot of money to heat or cool the air inside your home, and then that air is escaping or other air is getting in, just overall your home is not going to be as efficient. And so that's something pretty important and relatively affordable that we would highly recommend that you take a look at. Somebody also asked this question already: are all EV chargers for the home 50 amps? They are not. There's a lot of versions of EV chargers that you can get and install at home. Level 2 can be 20 amp or 30 amp, so they can be smaller. This is really similar to the selecting power efficient versions of appliances that I said before, but it means that you can still charge at home. You'll have plenty of distance. You won't get stranded, but instead of chugging all of that electricity all at once, your car is just like having a really nice set of appetizers throughout the day so that they're getting full, but just not all at once. You can also use various devices that I'll get into a little bit after this that allow you to share basically one circuit between a couple of devices that use a lot of power. Typically that's an EV charger and a dryer, but can be other kinds of things. And then there's also other appliance choices you can use that kind of combine two things. People are pretty used to having like a range, which is your stovetop and your oven combined, but sometimes those things are separate. And again, it can just make calculating how much load you have available on your panel a little bit more complicated. I already spoke a little bit about power efficient appliances. This is just, again, a little bit more of an explanation on that. And a quick note, they're also not necessarily more expensive. So you're not getting any loss of comfort. You're not spending necessarily any more money. You just have to look at how many amps is this pulling when you're going out and shopping for those new appliances. The biggest question that folks get, or that we get from folks when they're looking to optimize their panel is like, but am I going to have enough? People really want to make sure they have enough. And we really want to make sure people have enough too. People in the United States are used to a certain lifestyle, and you can panel optimize and maintain a really excellent lifestyle that will be fully comfortable and where you probably won't notice anything. So this fabulous data set for the other nerds like me in the audience is from an organization called HEA. These are PG&E customers in California. Each bar represents a home. The blue is the peak amount of use that a home had through the whole course of the year. That's, like Cora said, something that your utility and health and safety officials care the most about. When you're using the most power, that's when you have the most, potential risk of like frying some kind of wiring or doing something kind of dangerous in your home. So you obviously want to keep below that peak. You can see really clearly from these trend lines, most homes are not using anywhere near at their peak use. This is like, Thanksgiving, everyone's over, everything's on, you're running the heater, you're running kind of everything in your home. Peak use. Most people still only utilize approximately 30% of what's already available to them on their panel. So you can see the little red parens that I put over the section of 100 amp panels. Even folks with 100 amp panels, relatively low utilization. I will quickly note, these are not necessarily all electric homes, so there's some variability, but I have more data just in case that wasn't enough for you, to continue to demonstrate how possible this is for a lot of folks. Again, not everybody, but a lot of people. So this is a graph of over 20,000 homes, again, in California, what their peak panel size was. The blue line is just what was the number for their peak use, the maximum amps over a 1 year period. And you can see that there's lots of unused capacity on folks' panels. So a lot of possibility there. This is just a third one because probably you can have too many graphs, but I'm not sure that I'm there yet. This is even more homes from a different utility, from the Sacramento Municipal Utility District in California. They do break out gas and electrical customers. The difference between the total peak use between gas and electric customers, if you look at this, is not that big. For those of you who know Sacramento, it gets really hot there. Folks have a lot of air conditioning, and we're still seeing people way below 20 kilowatts. So that's the peak kilowatt demand is the x-axis on here. That's not even 100 amp panel, and the average is much less. So this data is partially why we feel like this is so possible for so many people. It is not without some effort to do this. It doesn't have to be a huge amount of effort, and there's a lot of work happening. But when you are updating an existing home and getting help from an electrician, they will need to use the National Electric Code to calculate what's possible on that existing panel. I'm not going to get into the NEC National Electric Code too much here. There's different ways to calculate it, and I'm going to show you why it's important. A lot of electricians are not familiar with this way of calculating total use. So there's folks trying to develop tools. One great tool that's in development right now is zerocarbon-home.com. It'll help you see kind of what available capacity is using these various calculations, which will help you approach how to make that electrification plan, work with your electrician to do that, etc. So this is a little bit easier way to understand these differences in National Electric Code that I was just talking about. And thanks so much to Josie Gaillard for putting these together for me. She's a member of our working group. So these demonstrate 3 different ways that you can calculate how much availability you have on your panel. So the far left one, the way that you do this is you look at, say, your stove or your heat pump, and it says you need 40 amps for your stove and 30 amps for your heat pump, and you add it all up, and oh my gosh, your panel is totally full. There's no space for anything else that you would want. And this is, again, an existing home. Per NEC 22.87, which is just another option for calculating. Probably none of you will ever have to do this, but your electrician might, and so it's helpful to understand how it works. You use your historical maximum. So those data sets I was just showing you, historical maximum, that's that teal. And then you add an additional 25% to that, just to like make sure there's a safety buffer, because safety is always first. And then on top of that, you add like the rated amps to your appliance. You can see even in this model, there's a huge amount of capacity technically available left on the panel. The third one is just demonstrating how much use this home, which this is a real home, all electric home, how much its peak use actually was, which is even below this other calculation. So this just gives you kind of a visual example of how these things are different. And based on the approach that you use to calculate it, or your electrician, unless there's a lot of electricians on here, will tell you, no, you can't add anything, you're totally full, versus what your actual use is. This is a pretty major sticking point in being able to optimize. A lot of electricians don't necessarily understand how to do these calculations or think it's too risky, even though they're like literally legally written into the code and have been for a long time. We do have some good news. There's a couple of national labs that are working on this with the Department of Energy to actually do a really broad study on actual use, current technologies, and recommendations to update the National Electric Code to be more electrification friendly, which would be phenomenal. Right now it's written really with a health and safety mindset, which is really important, but that comes at a real cost for electrification. So I'm not going to talk about this because Cora already did. If you do need to upsize, you can get some money. Quickly, because I'm going over time, and sorry for talking so fast, but happy to answer any questions for stuff I missed. There's also devices that you can use. Chad's going to go into smart panels, but there's a lot of other things you can do. One of the main reasons that people have to upgrade in California or looking at upsizing is that they want to get an EV charger or they're doing solar. This is where load sharing or load splitting devices can come in really helpful. If you have already an electric dryer that has a 240 volt wired plug, there are devices where you can plug in your EV and plug in your charger to the same plug, and they basically share that circuit. So if one is off, the other is on, and then vice versa. So say you come home, you plug in your EV, you decide that you want to dry a load of laundry, it will pause your EV, dry your laundry, and then turn the EV back on. You don't have to do anything. So there's a whole variety of devices. This is from Redwood Energy, almost a couple of years old now. There's already a lot of other things available that aren't even on here, and advances being made all the time. To devices like this, which are, again, a way to, without having to fully upgrade, allow yourself to live a more electrified lifestyle in a more affordable way. Just a quick notes on this. There is still a real diversity in how cities and jurisdictions are approaching these devices. It's something we're hoping to keep working on, but making them legal and accepted in a lot of places. Some of these devices are UL rated, which is like a full safety rating. So they are fully safe, but sometimes codes and standards are not able to keep up quite as quickly as other technology. So quickly, in the end, please avoid upsizing panel if at all possible. It saves you money. It's better for the grid. It's better for the neighborhood, and you're still going to be really, really well off. And if you do, just think about how you can do it as efficiently as possible. There are a ton of resources here. Again, some of the consultants are more California centric. I'm sure there's folks doing this in other places, but feel free to check these out. They are all really wonderful resources. Thank you so much. I'm going to go ahead and pass it to Chad.
Thanks, Hannah. I want to say huge thanks for that awesome presentation. And folks, while Chad's getting his slides going, just to let you know, we will send out these slides and these resources to everyone who registered for this webinar, and along with the recording that'll probably go out first thing tomorrow morning. Yeah, Chad, go ahead.
You're
All right, there we go.
Yeah.
Yeah, I was trying to get off mute. Awesome. Well, thanks so much, and great job, Cora and Hannah, really setting the stage here. And really excited to be here and talk with you all today. So I'm going to go into one of the options, and we'll talk about that a bit. So over the past 2 years, electrification really became a big thing, and Brian led off with that, but really just want to highlight that And we're so thankful that you all are here. The fact that there's hundreds of participants that are actually interested in electrification really means that we're starting to make some significant progress. And we just really encourage all of you to start talking to your friends and your neighbors and about electrification and your journey, because that will offer even more people to get a little insight and start thinking about what they can do to electrify. And it's almost like 60 years ago. So actually, in the middle of last century, there was a big move to electrify homes. Right after the World War II, we were starting to build a lot of big power plants, and General Electric and a few other companies and utilities got together and said, hey, we should really encourage people to use more electricity. And so then they encouraged this gold medallion home. And this was a highlight, making basically, as you're buying a new home, this is a gold standard for homes, is all electric. So excited that this is back and this is the future. And, you know, we talked about this, Cora and Hannah really highlighted that, you know, base case, you don't need this, right? So most homes today, their peak consumption is less than 30% of their current connection to the utility. As you start to add more and more loads, EV charger obviously is something that most folks are thinking about, but then also induction cooktops, getting rid of burning fossil fuels inside of your home and making a healthier and safer home. And then things like water heaters and dryers, you start to kind of add onto that, and the calculations start to look not so great. And like, oh, I have a 100 amp home, I think I'm going to have to be at 200 amps. And we're happy to say that there are a lot of solutions. The circuit sharing devices, the ability to do different calculations and look back at that historical consumption really proves out that most loads are cyclic and not coincident. So, you know, it's really only that Thanksgiving day where you've got the whole family over, air conditioning cranked up because the kitchen's hot because you're cooking all the, you know, delicious meals. That's when there starts to be a challenge or a risk of a challenge. It may not actually happen because you think about air conditioning, and folks that have a ducted system will hear it on, right? And comes on and it's blowing that cold air, and then all of a sudden it hits temperature and turns off, right? And it comes on and off. And so most loads are like that. Even your oven, it comes up to temperature, hits the temperature and then turns off. And then, you know, as it gets cooler, it turns on again. So the truth here is that it's very infrequent that you stack all the load, but smart panels can help you avoid those. And we're going to talk about that. The really big challenge, and we've talked about it already today, so I'll skip over this pretty quickly here, but it's very expensive and takes a long time to get a service upgrade. And so we want to avoid that because we need to electrify fast and we need everyone to electrify. Therefore, it needs to be equitable. This is you know, what it looks like to have a load profile that will go over your 100 amp connection. And you can see those orange spikes there. And what if you could pause those loads that cause you to go over your connection to the utility and just move them a few minutes outside of that coincidence and have them turn on a bit later? And many of these things you won't even notice. So things like EV charging, if it's paused a couple of minutes, it's not good. You're not going to notice. Your car is still going to be charged in the morning. And going back to Cora, you know, it was really great to work with Rewiring, and we're going to continue to work with them on studying data across our thousands of customers throughout the United States on their current peak consumption. And we have data not just on the peak consumption, but also at the circuit level and appliance level, so that we can see what loads are coincident, what are actually turning on at the same time, and when. We're really excited for this year. You know, we've got Thanksgiving coming up in here just over a month and a half, and we're going to get all this great data of the big families over and see how people consume power during the holidays. And so the cool thing about SPAN is we're a certified energy management system, and that means that we can turn on loads and turn them off when needed. And so that allows us, again, to stay under that 100 amps. So if your current home has a connection to the utility that is rated at 100 amps, we can keep that. No need to contact the utility and wait months or spend a lot of money on running new wires underground or anything like that. We can just swap out your panel, and one device solves your electrification. And this is just a graphical representation. So the top looks like, you know, the home before adding the electrification. And then the second one here is if you add an EV charger, and you'll see in the evening, you'll kind of peak up above that 80% continuous limit. And then at the bottom, it shows adding span allows us just to shift that EV charging consumption a few minutes. And then we're able to have that whole electrified home powered on a 100 amp service. A little bit about SPAN. We're on a mission to enable electrification for all. And so we are developing technologies, and our first one is the circuit breaker panel. And we'll be continuing to develop more. We're going to talk about the EV charger in a minute here as well. This is what a SPAN panel looks like. So gone are the days of the rusty old gray box, and in are the classy, beautiful panel of the future. And those photos with the mint or teal on the left are actually my house. And then you can have it installed inside, outside, flush mounted, surface mounted. It's really flexible. So wherever your existing panel is, we can put it right there. The smart panel is made up of a number of different features. And so we've got basically your standard outside enclosure that's, like I said, meant for installing indoors or outdoors. And then the backplate has a connected gateway that sends all of your data to your mobile app. And then we can land just standard breakers. So this solution doesn't rely on any new breaker technology or anything. You can go out to Home Depot or Lowe's and get a new breaker, and you can use your existing breakers on SPAN as well. And then of course it's got the beautiful front door as well that can be flipped to the left or the right. We're one of the only panels that has the ability to open either way, and that really just makes it even more functional and usable within your home. Oh, and I forgot to mention, we have LEDs. So gone are the days of holding a flashlight in your mouth trying to figure out which circuit trip. The hardware is paired with an amazing mobile app, so that you can see your consumption, not just at the whole home level, but at the circuit level. And you can also see what appliances are using the most energy throughout the day or the month or the year, and make efficiency improvements. So say, you're seeing that your peak consumption is really high due to an old air conditioning system. Well, upgrade to an efficient heat pump, and then you can lower your consumption and make it easier to add more electric appliances. And that's this middle screen here. You can see each individual circuit, what it's consuming right now. And the cool thing here is that if you leave the house, and we've all done this, and you're 30 minutes away and you say, gosh, did I leave the oven on? Well, you can go in your SPAN app and just check it out. And if in fact it's on, you can actually turn it off right there. And then when you get home later, you can turn the circuit back on, and all is good. SPAN pairs with battery storage systems. So we pair with all the market leading battery products, the Tesla Powerwall, SolarEdge's battery, and Enphase battery. And that offers resiliency. As we electrify, it's really important that we're able to manage through these historic, natural disasters that we have, whether it's fires in California, tornadoes in the middle of the country, or even hurricanes in the Southeast. And SPAN enables the system to automatically unpower some of your loads that are high consuming and not high priority for you. So this screen on the right shows that we can reprioritize our loads on the fly, and such that if there's an outage, it automatically shifts some of those non-essential loads off and just powers the ones that you want to be powered. Things like your refrigerator, some certain outlets and lights in your home. And that means that we actually can extend your battery backup 40% longer, so that you can make it through a longer outage. And that's really important for resiliency of electrified homes. Touched on this really briefly. We just started installing our EV charger product. Now, why is EV charger so important? It's something that we're all thinking about. We need to electrify our vehicles. We need to electrify our homes. And where do they meet? They meet at the EV charger. And the EV charger is something that you want to make sure you get a ability to charge up your car in overnight. In the time that it's plugged in, it needs to be fully charged. For some folks that have a short commute, that doesn't mean much. You can plug into a wall outlet. For other folks with bigger vehicles, that really means that you need to have a fast, high-speed charger. So SPAN enables level 2 charging for any home. So whether it's a 100 amp home or it's a 200 amp home, they both get the exact same experience of fast charging at 48 amps continuous. That's a 60 amp breaker. But guess the additional to your load calculation, it's 0, because SPAN is a certified energy management system. And so we can actually ramp up and down the EV charging speed based on your current home consumption. So on Thanksgiving Day, when everything's on, we just ramp it down and charge a little bit slower while there's coincidence. And then as soon as the air conditioning turns off, ramp it back up, back to high-speed charging. And of course, just like the panel, we tried to make it really beautiful. It needs to, be elegant, something that you want to have. And we all know that we attribute value to things that are attractive and beautiful and that we can highlight. And SPAN is a product that gets better over time. We offer over-the-air updates, and I'm really excited about this feature because my home has solar, and I want to be charging my car 100% on sunshine. Therefore, what will happen is that the charger will ramp up and down charging based on how much energy is coming out of your solar panels. And we can match it to the solar output, or we can match it to the energy that you would have sent to the grid. So we can match EV charging to that export energy. Also, charging during an outage, something that's important. Sometimes we have an outage, we need to get out of here. And that's going to be even more important because gas stations don't have power, they can't pump gas. But if you're at home and you've got EV charging on a backup battery system, you can charge your car. Also, as more and more families go 100% electric vehicle charging, you want to be able to just plug your car in at night. And again, if you have 2 EV chargers at 60 amp breakers or 48 amp continuous, that's a pretty big task on 100 amp service. But with SPAN, because we can modulate the charging power of the chargers, we can have 2, 3, 4 EV chargers, even on a 100 amp home, which is really awesome. And we hope that you all join the electric revolution. This is we've got thousands of customers across the United States already enjoying SPAN products, and we hope that you become one soon. Thank you.
Wow, that was great, Chad and Hannah and Cora. That was fantastic. Wow, I've got a lot. There have been tons of questions in the chat, and I've got quite a few of them myself. So I hope we have some. Looks like we got some. We're going to go over a little bit here, and hopefully the audience, you can stick with us for a while to answer some of these questions. But that was fantastic. I want to start with. I got a ton on the smart panel thing, but maybe before we get to that, Hannah, you touched on this, but it seems like. Okay, it's hard not to hear all the information you were talking about as a homeowner and be a little confused, like, how do I navigate all this? And it feels like some of this is going to come down to the electricians who are always going to be our trusted advisors on these things when we don't want to do all those calculations ourselves and get in there and risk shocking ourselves, etc. So how do we get over what I would imagine is a big hurdle, which is that a lot of electricians are just going to want to do it the old way, buy the book, and they're going to tell you need a bigger panel. So if it feels like there's some craftiness and ingenuity involved in these panel optimization strategies that might be really beneficial to avoid having to do those bigger panels. But if our electrician's telling us that you just got to put in a bigger panel, what do you do about that?
It's such a great challenge, and you're right. It is definitely a hurdle. My parents are literally trying to do this right now. So that's where the link zerocarbon-home.com might be really helpful if you get, so like I'm in PG&E territory, that's a large swath of Northern California. You can actually download your own usage data. This is probably possible with other utilities, plug it in there, and it'll help you actually calculate some of these things. And then even, I think it does it now, or and if not, they're working on updates so that it actually will print out what you would need to then take to a utility to apply for doing this work or getting it approved. But you could also use it with your electrician to have a conversation that's a little bit more informed than what you might be able to have otherwise, to say like, look, here's what I'm trying to do. Here's what the code says. Here's my actual use. It's all here, and we can have a conversation about it that's a little bit more informed, because the retraining of the existing electrician workforce, particularly in residential, it is definitely a big hurdle. There's also some education being put out there for electricians. So PG&E offers a number of courses on this, as well as other practitioners who are really at the vanguard. So like, for example, the company Electrify My Home around us does trainings for local electrical groups, electricians. So finding some of those and seeing, like, if you're interested in doing this, looking to see if there's programs like that near where you are, to see if they have graduates or other folks who advertise this.
Yeah, I was curious about that.
There's demand is huge as a homeowner.
Because I'm wondering, because we face the same issues with plumbers, with heat pump water heaters, and even HVAC folks can be on the leading edge of embracing this technology and telling you don't need gas backup, for example, for your space heating, versus others who are going to be a little old school on that. So I'm wondering, are you seeing any resources in terms of like electricians who get it, who are doing this work, and here's who they are and how to find them? Are you seeing anything like that? Either of you three?
Not outside of like the list of folks who I know are involved. Maybe Electrify Now could create that resource, because it would be so useful to have.
Cora, are you seeing anything rewiring on that front?
We don't have anything right now, but that's definitely something we've talked about, creating a list of HVAC contractors or electricians who are kind of on the leading edge of electrification.
Yeah. Okay. Thanks.
Well, we all might have to do some educating of the trades ourselves as leading adopters. I mean, one question just stuck out to me, and maybe if all three of you wouldn't mind, chatting about it. Are there any comfort sacrifices or other potential negative consequences to users to more power efficient appliances? I don't know who wants to take the first stab at that one.
Did you say me? Sorry.
Go for it if you want. Go for it. Yeah, go for it.
I don't need to. I've done a lot of talking. Chad, if you want to take it.
The cool thing is that comfort and your needs are prioritized first, right? And so all of these technologies that we talked about today really take the customer and the homeowner and you all really as the it's your home, and you can prioritize it as you need. And cool things like what we're talking about, shifting and pausing, is that there's some devices that you won't know that when they're on. We don't know when they're on. We don't go out there and say, oh, is the water heater on or EV charger, right? We just know that we have hot water, and we know that our car is fully charged in the morning. So we're not talking about any inconvenience here. All of these things just enable a more efficient use of both the infrastructure in your home and also the infrastructure on the grid.
I mean, related to that question is this whole issue of demand response, which we haven't really got into a lot. But you know, obviously here in Oregon, PGE is really doing a lot of work and experimentation around demand response, and they even have programs where they will pay you not to use electricity at certain peak power events. And so it seems like this this notion of a smart panel, for example, and or smart switching devices even, and demand response is really related, because, for example, one of the things we hear is that there might be a future where the utility could turn your water heater off during peak events for a couple minutes or even an hour or something like that. And again, you wouldn't even notice it because or you could turn it on before the event to make sure you got really hot water, and then turn it off during the event. But it feels like that issue of demand response and smart panels and loads is so related. Do you see a situation where we might even be, are utilities thinking about potentially even like incentivizing these kinds of solutions because it helps their management of the grid? Anybody hear anything about that?
Yeah, so Silicon Valley Power just offered a new rebate that's $2,000 for panel upgrades, specifically focused on smart panels. So because if we all adopt 400 amp panels, which, you know, old school electrician math, you know, it's basically like, okay, well, we've got all of these large appliances, let's just upgrade to the largest size possible because that's the safest thing to do, or most conservative. I shouldn't say safe because it's all safe, it's all protected by breakers. That's what the safety device is. But the most conservative thing to do is upgrade to 400 amps. And if we all upgraded 400 amps, that means all the wires and transformers and everything throughout the grid has to be upgraded to be able to provide power for that amount of consumption, that peak power, which means that we all have to pay through our utility rates for all that additional infrastructure that nobody's going to use. So, you know, the really best thing to do here is to further educate homeowners and electricians throughout the country on these technologies and these efficiencies. And we are seeing a lot of utilities see the opportunity to, instead, we're working with many of them to implement smart panels and smart technology to monitor the appliance and total consumption of homes, and then also just better utilization of their existing infrastructure. And with that, of course, there's so many layers of benefits because the demand response piece is also there, right? And especially at times when California grid, it was in the news a lot in the past month about being constrained and not having enough generation. So you can solve the localized problem of not needing to upgrade the wires and transformers, but also the total consumption problem with demand response, all with the same devices.
So is the span panel demand response, I mean, can the utility interact with your panel?
We have a couple of pilots going on right now. Green Mountain Power was the first one to jump on board and install hundreds of span panels in their customer homes. And they're able to send a command to do demand response with certain appliances that are connected to the span panel.
And just quickly, we talked to a number of utilities, and a lot of them are definitely thinking about ways they can incentivize, overall grid health and resiliency through things that homeowners can use. I see in chat, there's folks here from PG&E that are thinking about it. And I know that others definitely are as well, but I still think a lot of them are in the kind of the research phase. So it's a little bit early days.
For one, kind of, if we want to be succinct about the takeaway for some of our listeners, it's that even with 100 amp panels, there's lots of strategies and you have plenty of electricity to electrify everything. We also want to say, as someone wrote in the Q&A, that a lower rated panel is more climate resilient. Is that a statement we want to make?
I think so, especially because, as you think about your backup battery, you don't have to get as big of a backup battery. For example, the heat pump water heaters, right? Traditional electric water heater is 5 kilowatts, and a heat pump water heater Mine consumes about 350 watts. And a traditional backup battery, say a Tesla Powerwall, is able to put out 5 kilowatts. So if you turn on the electric water heating during an outage, you're going to be peaking out and then you can't have anything else on. But if you have a heat pump water heater in the heat pump mode, you can be running the water heating while you have the lights on and really in just living life, even during an outage.
Is there anything around vehicle to grid that impacts what we're talking about? I mean, I think for the most part, we've been talking about taking loads out of the house, or sorry, out of the panel into the house. But is there anything about vehicle to grid that is relevant in this conversation, or is that just more of a separate conversation?
I think it's a bit of we're really excited about it. We're really excited about vehicle to home and vehicle to grid. Mm-hmm. But I think it's still we're really kind of figuring it out. I think there's been hundreds of studies that have said if we can use these batteries that are going to be deployed throughout the country in people's garages and at the workplace, it will enable us to not have to deploy as many batteries, not have to deploy as much new generation. But there's only really a couple of vehicles on the market that are able to do any form of it today. Where I think we'll see the biggest use case, at least initially, is really vehicle to home during the grid outages, where you'll be able to power your home from your vehicle. Because really, you don't need that much battery to back up a home when you're not home, right? You want your refrigerator still to be powered. That's probably about it, right? There's not really anything else that, if there's nobody at the house, that you need to keep powered. But when you get home, you might want to run water heating and air conditioning and or lights and things like that. And that makes sense. You've already paid for this beautiful vehicle that's got all this capacity in it. So it'd be great to be able to utilize that to back up your home.
Great. Let's talk a little bit of cost. I mean, a couple of the studies that Cora and Hannah cited, the panel upgrades to go from 100 to 200 amp might cost you anywhere from a couple thousand to much higher than that. And then someone in the Q&A is kind of looking at the span costs of, $4,500 for span, smart panel. Chad, so maybe you could talk a little bit about the cost for span, and then how do folks take into consideration the costs of what they should think about when trying to maximize their 100 amp panel.
For sure. There's lots of technologies. These circuit sharing devices are very economical. They're only a couple $100. So that's a great place to start. And then as you start to look at, well, do you have enough circuit breakers space? Are you going to be getting solar and battery storage? So these are starting the questions that you really have to ask. And if those things are yes, if you're going 100% electric and you're probably going to get solar and battery storage, then that's when you start to think about span. And you can wrap that into financing that allows you to pay a really low monthly rate and get solar, battery storage, span, and some of your electric appliances that kind of decreases the total upfront cost, because it can be expensive. Span, as you mentioned, is $4,500, but then you also have other appliances that are several $1,000s, right? And that's where financing plus the Inflation Reduction Act plus all these rebates from utilities and local municipalities, they all add up, and we're going to see that the cost is way lower to actual consumers starting, just next year with the Inflation Reduction Act.
Cora, did you have something to add to
that? No, I think Chad covered it. Yeah. Yeah, I guess I'll just say quickly another plug for these circuit sharing devices. I think that's, each circuit costs more money. So in my home, I've got a gas dryer right now, and, we're planning to basically use the same circuit for EV charging and for putting in an electric dryer.
Yeah, it's so smart. I mean, there's just so many things that you don't need to be running at the same time. I think the other thing, just you guys mentioned it, but 50 amps for charging your EV, it's like, wow, I mean, I don't know who needs that. I mean, that's like, if you're spending a night at home with a 30 amp circuit, you're going to be able to get over 100 miles easily of charging, which is pretty hard to like beat. It's hard to kind of really, it's hard for that to be a problem. I mean, I'm sure there might be some situations, but I guess my point is I think people often really overestimate how much power they need for EV charging. I mean, I've done a lot of it with 120 volts and 20 amps, and it's been fine. So anyway, just a little plug there. I did have one question about your span drive, by the way, Chad. Do you need the span panel in order to run that, or can that be run independently?
Yeah, right now it's has to be paired with the span panel. So all the brains are in the span panel, and the EV charger really is just that connector to your car.
Gotcha.
Great. Well, Brian, did you have any last questions, or should we call this a day? And
I think we're probably pretty good. I know I don't know that we answered all the questions in the chat. There were a lot there, and I appreciate everyone's participation in the chat and the Q&A. I hope we answered most of your questions. If you have anything that's really bugging you, definitely email Joe or I. We'll try to make sure we can get your questions answered. And no, I think we're good. I think we should just say thank you very much to our amazing panelists. You guys are great. Thank you so much for the work you're doing. It's really helping. And appreciate you being here today. And to all our audience, I would say thank you for tuning in and good luck with all your electrification projects, and hope to see you sometime in one of our upcoming events.
Thanks so much, everybody.
Thanks, Joe and Brian, for hosting.
Thanks all.
Have a great day.
Bye-bye.
Thank you. Bye.